No, all good. Thank you very much. And thank you very much as well for giving me the opportunity to present to you this study which we have performed in Germany for the German cement industry. It's a roadmap, how we call it, for the way to decarbonation of the German cement industry. And I can tell you this was a real challenge also for us doing this work. Of course, today I will only have the time to present the final results, but all the single topics I will touch upon are worth, let's say, to go much more into detail, and perhaps we will have the opportunity to do it at another time. So I will start with a very short overview of the German cement industry. I think the cement people among you know a little bit about the German cement industry. These are the key figures of 2021. So we have in Germany 21 companies with 54 cement plants, 33 with clinker production, and 19 grinding station and two mixing plants. And maybe important as well, we had last year about 35 million tons of cement production, was a very good year, and about 25 million tons of clinker production, 38 rotary kilns. And you can see that the cement plants are well distributed over the country, across the country, always there where we have the limestone. When it comes to greenhouse gas emissions, in the cement industry, we mainly talk about, or nearly only talk about CO2, because fortunately other emissions we more or less do not have. And what is very important, and this is the main difference, for example, to the power sector, the cement industry has, as you will know as well, has about 2/3 of CO2 emissions coming from the decarbonation of the raw materials, so from the limestone, and only 1/3 coming from the combustion of the fuels. That means that in contradiction to the power sector, which can switch to renewable energy, this is not possible for the cement industry, of course, to some extent, but the limitation is this 1/3 which could be replaced here. And still there will remain the 2/3 of CO2 emissions coming from clinker production. A short look into the history. We see here the development of total CO2 emissions and specific CO2 emissions per ton of cement for the last 30 years, so starting more or less with the German reunification. And as you can see, we had a drop of about 23–24% for both values. And what you can see as well is that we had a quite steep decline in the first years after the German reunification, where we had a lot of investment in the new countries, how we call them. And after that, there was a more or less stable, with some fluctuation, development. But if you have a look to the upper line, which is the specific line, you can see that during the last 3–4 years, we again had a small decline. And I think it is good to say that this will also be due to the CO2 prices which we have in the European Union with the EU ETS. We have it already for many years, but the CO2 price increased over the last 5 years. Today we are above 60 euros per ton of CO2, which is really a significant value. And we will come back later to some prices or costs of measures. And then we will see that with the 60 euros per ton, it starts becoming more and more worth to invest in measures. Yeah, why did we do this? I mean, the background of climate change and European policy I don't have to mention here. You are well aware of this. But also as a German cement industry, we thought 2 years ago that we really have to show or to investigate, first to investigate how will it be possible to achieve these targets of the European Union for the cement sector. And there was already a roadmap for the European cement industry, and we wanted to break this down to the German sector, also much more technical as we do it, or as we are used to do it at VDZ. And then the next point was, shall we only have a look to the cement industry? So just taking the 20 million tons of the cement industry and try to get rid of it, and then the full value chain is climate neutral as well. But then we saw quite quickly that this is the more difficult way, and it's also not the most efficient way. This is why we decided to look at the whole value chain. So not only looking at clinker, but to looking at the whole value chain. And I will come back to this with the next slide. Then, of course, we have seen that there are a lot of challenges for industry on the technical level, of course, but also on the political level. So the question: which technologies and innovations are needed? We know that we are with the technologies which we are or have implemented today, we are really at a limit. We really need breakthrough technologies to make this possible. And then the question: what are the external prerequisites for a climate neutral concrete production? And this document is available on our website. The long version is in German, but there's also a summary in English. Yeah, looking at the whole value chain, this means that we, of course, looked at the technical potential of reducing, further reducing CO2 emissions from clinker production. But then, of course, we also have to look, or had to look, at the clinker-cement ratio, so on cement production, and then the question on how much cement is needed per ton of or cubic meter of concrete, how much concrete is needed to build something, a building or a bridge or whatever. And then last but not least, we also included what is called the recarbonation, so the natural recarbonation. You may know that concrete in its lifetime also takes up again CO2 from the atmosphere. There are many studies about this, and this has also been included. How did we do this? We defined two scenarios, one which we called ambitious reference scenario. So it's not only business as usual, but it's really looking at technologies which are available today already, let's say in the lab or in the pilot scale, and implementing this in the sectors. And then a second scenario, this green field here, which is the climate neutrality scenario. Here we took everything into account, what we think could become possible or technical achievable in the next 30 years. We defined the scope on the direct emissions. These are well known and yearly reported by the companies within the EU ETS, so these are data which are publicly available. And we did not include, for example, the CO2 emissions from mobile sources, which are really minor in the cement industry, and we did not include indirect emissions from power consumption, because we assume or took as a boundary condition that the power generation in Germany will be more or less renewable in 2050. So no greenhouse gas emissions anymore from power generation. Then the next question was, we are technical people mainly at VDZ, so of course we start looking at our clinker kilns and at the cement mills. But very soon we came to the result that we have to start at the back end, which is construction, and the question: how much concrete will we need in 2050 in Germany, and which raw materials will be available at that time? Starting to look at the materials which we use today. There will be big changes. I will come back to this. But for example, fly ash will disappear with stepping out of coal firing and power generation in Germany until 2038, and also slag, like we know it today from blast furnaces from the steel industry, will more or less disappear. or at least be significantly reduced, which is bad for our clinker cement ratio, and we have to look which materials can then be used instead of those. So coming then from construction and concrete demand, we went back to cement demand, so how much cement will be needed, how much concrete will be needed, and then we went back to how much clinker will be needed in order to achieve these objectives. And based on this, we took quite many assumptions. We had to take many assumptions. I mean, these are already now the measures which we took as a basis. On the left-hand side, you see always the what we call the ambitious reference scenario, and on the right-hand side, the climate neutrality scenario. And this slide is valid for clinker and cement production. I will come later to the concrete and construction part. With regard to thermal efficiency, we have calculated already a couple of years ago, we made a study on this, that we can improve thermal efficiency by 13%. There's a lot of technical calculations behind, but please take it as given here. And we think this has also been done already in the ambitious reference scenario. So this is the same then also in the climate neutrality scenario, because this is everything what can be done regarding thermal efficiency. Alternative fuels. You may know that Germany is quite high already today in alternative fuels. I will show a slide, next slide then. And perhaps I will start with that and then come back. Okay. So this slide on the left-hand side and the left part shows the shares of the different energy providing, let's say, materials. So the grayish are the fossil fuels, the green field are the alternative fuels, and blue is electricity. And what you can see here is that the alternative fuels have, the share of the alternative fuels have increased significantly over the last 30 years. And today we are on a level of about 70% by energy. This is for 2020 here, the fuels breakdown. 70% by energy or 75% by mass. And you can see the big, let's say, dark orange field, the 47% are mixed industrial waste. So this is the RDF, which you also, what I learned yesterday, use in the Lukavatz cement plant. But there's also, for example, sewage sludge, which takes a big share, at least when it comes to mass. We use still alternative waste tires, for example, a little bit of waste oil, a little bit of animal meal, and then also pre-treated municipal wastes. So it's also kind of RDF, but a slightly different composition. So 70% is where we are today. And going back then to the measures. So we think that it will be possible in the ambitious reference scenario to go up to 85%, and in the climate neutrality scenario even to go up to 90%. I would like to mention that we also already have today cement kilns running at more than 90% as a yearly average, so we know that this is possible. And the main challenge is the availability of these materials. And I mean, we will come back to the alternative fuels and the waste fuels later. But of course, the availability will depend strongly on the policies regarding resources sufficiency in the European Union. So, for example, will plastic waste be available in the future? To be honest, we don't know. And it will be different for sure. Yeah? So nevertheless, we are convinced there will be still sufficient wastes available which can be treated to fuels which then can be used in the cement industry. And we have assumed that this will contain about 30% of biomass, which is more or less the same value which we have today in the alternative fuels being used in Germany. In the reference scenario, we have assumed that the remaining 15% will be coal, conventional fuels, and in the climate neutrality scenario, we have assumed that it will be hydrogen. Hydrogen is, it's very sexy at the moment. Everybody is talking about hydrogen, but I can tell you, last week we participated in a big test in a cement plant in UK, where we replaced 40%, 20% of the total fuel energy consumption of the kiln system, which was about 40% in the sintering zone, with hydrogen. And I can tell you there was no negative effect. It was like going to natural gas. So we ourselves were really surprised. So that was the first big test, industrial test as far as we know. And it was very, very positive. And then regarding CCUS in the additional carbon capture and storage and use, we assumed that in the reference scenario we will not use it. In the climate neutrality scenario we will have to use it. And on the cement level, we have different scenarios. I will show this with the next slide. So we'll focus on the CEM2C cements in the reference scenario and achieve a clinker cement factor of 63%, while in the climate neutrality scenario, we will focus also on the CEM2 cements, but also on the new CEM6 cements in order to come down to a clinker factor of 53%. And in the clinker neutrality scenario, we also assume that we will have 5% market share of new binders, which are being developed already for many years, but today we don't have them in the market. Sorry, I think this was the wrong button. So here we see how it will develop with the clinker factor. On the left-hand side, the reference scenario. On the right-hand side, the neutrality scenario. And let me focus on the neutrality scenario. So you can see the different cements with different clinker content. So the grayish one is 35 to 49%. And the bottom dark blue is the CEM1, so 95 to 100% clinker content in the cement. And as you can see, this grayish part, which are the CEM6 cements, as well as the CEM2 cements, the green part, will have to decrease significantly in order to achieve this clinker factor of 53%. What does that mean for the raw material mix for cement production, I must say, in Germany? So in 2018, we had 24 million tons of clinker, and this would go down, if this assumption will come true, to about 15 million tons. Blast furnace slag, as I mentioned already, will come down from 5 to 2 million tons. I will not go into detail. Even this is a big challenge, these 2 million tons. Limestone will increase significantly because these new cements will require more limestone. Calcined clays will come into the market by nearly 4.5 million tons, so really significant, but there's also a big move at the moment. Fly ash, as it is in cement here, will disappear. Fly ash in Germany goes mainly into the concrete, but there also it will disappear. Okay, we need the sulfates, of course. So, and you see the clinker factor once again. So already this, to meet this raw material scenario, this is a huge challenge. Sorry, I'm always pressing the wrong button. I come to the technology mix and the assumptions for concrete and construction. So first of all, we think that in both scenarios we will assume a differentiated use of cement in concrete depending on the requirement profile, so which will be a big challenge for the construction site itself. We think that we will have advancements of concrete construction methods and also an expansion of industrialization in the reference scenario, and especially in the climate neutrality scenario, this will be extended even further. And we have the recarbonation with 20%. So and this is the final result. On the left-hand side, you see the about 20 million tons, which we had in 2019, tons of CO2, and you see the different levers which have to bring their share. And what remains is the big bar with the 10 million tons, which will be reduced by carbon capture. Yeah. Only one slide about carbon capture regarding costs. I can tell you that at the moment we have in Germany the planning phase for 2 carbon capture projects. So 2 oxyfuel kilns will be built are being planned to be built in Germany at least. So this is what is also publicly well known. We have the different technologies, but when it comes to costs, it's a bit small here, but you can see that capture costs are today between 40 and 90 euros per ton of CO2. Then we have the transport, which is also a huge challenge to set up a CO2 infrastructure, and then the storage costs or the utilization costs, which bring the cost up to beyond 100 euro per ton of CO2. And when we talked in the beginning about EU ETS and the 60 euros which we have today, you see that we are not there to make this really economically viable. My last slide, the prerequisites, what we have. So it's not only technology, it is also the availability of sufficient renewable energy and power grids, which we don't have today in Germany, by far not. A suitable infrastructure for the CO2 transport. A cement plant produces 1 million tons of CO2, and if you capture it, you have to do something with it. We need a policy framework for the competitiveness and innovation, has been mentioned by previous speaker already. We need a market for these low and carbon neutral cements and concretes, because they will be more expensive than today. And of course, last but not least, we will need a societal acceptance for this industrial transformation. And I would like to end with a word, it has to be, we always say, yes, it has to be done, but we have to do this. Thank you very much.